Hello and welcome back to our next video in our little series here on compound interest. In this video, we are going to examine a couple other formulas related to compound interest. One formula we have is the present value formula, and another formula is the continuously compounding interest formulas. Up until now, we have been examining future value formulas from the first video, but in this video, we are going to look at present value formulas. So the present value formula is determined by solving the future value formula for p. Simply divide both sides by the quantity 1 plus r over n to the nt power, and you will have our formula. P is equal to a divided by 1 plus r over n to the nt, or as it may be written, this could be equal to a times the quantity 1 plus r over n to the negative nt power. And this formula is used if you want to know how much to deposit into an account today in order to achieve a certain amount in the future. So here's an example. Suppose you wish to help your child pay for college. Suppose you are counting on scholarships, but just in case, you want to have $70,000 in an account ready in 20 years. So how much would you need to put into an account today that earns 6% interest compounded monthly? In this case, we're going to use the present value formula. And the key to this is it literally asks in the question, how much do you need to put in the account today? Today is present, so that's why we use the present value formula. Our A value that we're achieving is 70,000. Our time frame is 20 years. We are talking about our annual rate being 6%, so we convert that to a decimal, 0.06. And then our compounding monthly means that n is 12, and that's how all of those words translate into our formula. And when we do the calculation, we get about $21,146.73. So if we deposit $21,146.73 in an account today that's compounding monthly at 6% interest, in 20 years we should have $70,000 to help pay for this child's college. The continuously compounding interest formula is used if interest is compounding every second or faster. Such situations do exist when accounts are done between governments or international corporations, but they're usually not available to the average consumer. Since compounding occurs faster than a second for these situations, we need to use the approximation that 1 plus r over n to the n power is equal to e to the r. Now, e is that number, 2.71828182845, etc. It's that irrational number that pops up so much in applications. With this approximation, we may condense our compound interest formula to be read as a equals p times e raised to the rt power. The present value formula, of course, just solve this for p, and you have a divided by e to the rt would be equal to p. So let's find the future amount in an account if $10,000 is deposited at a rate of 6% compounded continuously for 15 years. So in this situation, we are looking for the future amount. So A is unknown. P is the present amount or the principal, and that's the $10,000 we're depositing. The rate is given to us at 6%. We convert that to a decimal, so that's 0.06 for our formula. And the time frame is 15 years. Now, it did say that we're compounding continuously, so that tells us to use the continuously compounding formula. We don't need the 1 plus r over n to the nt power. We're going to use the formula that's commonly referred to as PERT, as it spells that out. So we're going to do the following. A is equal to p times e to the rt power. We plug in our values, do the arithmetic, and the future amount of $10,000 deposited into an account compounding continuously at 6% for 15 years comes out to be approximately $24,596.03. Find the present amount if we need $10,000 in 7 years. and the rate compounds continuously at 8.4%. All right, so now we're doing a present value calculation. Here we know the future value is 10,000, but the present value is unknown. So this question here says find the present amount, but sometimes they may be worded as what's the amount I would have to deposit today. Remember, that phrasing means you're going to need a present value formula. The interest rate is 8.4%, so we convert that to a decimal, 0.084. The time frame is 7 years, and again, we are compounding continuously because the problem says so. So we're going to use the A divided by e to the RT formula. We're going to plug in our values, and we end up with $5,554.34, or 37 cents, sorry, approximately. And this is how much we would have to deposit in the account today under these circumstances. And this is how you can use the present value formula as well as the continuously compounding formulas to answer questions. Our next video will discuss in detail the effective rate. So we will pick it up here for our next video, and I thank you for your time and attention.